All right, section 5.1, we're doing nth roots and rational exponents. Okay, so our objective is to find nth roots of numbers. So far, we've been dealing pretty much with square roots. We write them that way, like the square root of 25. Okay, where we're dealing with things to the second power, squared. Okay, now we're going to up the ante a little bit. We're going to get into things that are cubed, cube roots, fourth roots, fifth roots, so forth, and so on. Okay, okay, so that's going to be our very first objective. Okay, we're going to evaluate expressions with rational exponents. Rational. Whenever you see that word rational, if you don't have a highlighter, you will need one, so pause the video and go get one, please. Okay, rational is really our mathematical way of saying things as a fraction. Rational or fraction exponents. Rational numbers can be written as a fraction. And then we're going to solve some equations using these nth root ideas. Okay, so let's go to some place we're comfortable. The square root of 16. And I'm sure we all know the square root of 16 equals 4. And the reason for that is because 4 to the second equals 16. If you notice, we're taking things here to the second power. Okay, so there's our power. So, and when we say this is a square root, really we're saying, and it's not written in there, but putting a little bitty 2 inside that little crook arm, putting a little 2 inside that little crook, see my little 2 in there, tells me that we're taking these to second power. We don't normally write this 2 in there. That's kind of what we think is understood. We know if there's no number written in there, we're dealing with taking things to the second power. Okay, but we could write the little 2 in there. Okay, we just don't. It's kind of one of those, hey, it's understood, it's square root. Okay, this little 2 is what we refer to as the index. Basically, it tells you, what power am I going to? What power are we using? Are we using second power to the third power to the fourth power, so forth and so on? Okay, and so this little number out there is called the index. Sorry, that little 2 out front there is called the index. Okay, and this 4 and the 16 inside of here is what we call the radicand. So this 16 is what we call the radicand. Okay, it's wondering what do we want to equal when we go to that power. Okay, so then when I have, let's say, the third root of 8, really what I'm looking for is I'm looking for something to the third power where I get 8. Okay, so to help me figure out, well, something to the third power, I'm going to list some of my thirds. Okay, so to help me on that, it's helpful to have a list of our thirds. Like, we know our squares. For the most part, we know our squares. Okay, 2 squared is 4, 3 squared is 9. Oh, 1 squared is 1, 3 squared is 9, 4 squared is 16, 5 squared is 25, ... These are our squareds. These are our n's to the second power, something to the second power. We know those. Okay, our thirds we might not know as well, so this is where our calculator can come in handy. We're just taking numbers to the third. So 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, ... Okay, so we're looking at numbers to the third power because my index out here is 3. Okay, so we're looking for what number to the third power is 8. Well, we found it. That was this one. It was 2 to the third. So the cube root of 8 is 2. Okay, because 2 to the third is 8. Okay, so that's why the cube root of 8 is 2. Okay, so depending on our index here, okay, we're looking for some number here. If I have an index of n, we're looking for some number to the n power, and we want to get a. Okay. Okay. Another way of thinking about these nth roots of numbers is to think of them as exponents. I'm going to grab a different color. We can also think of them as exponents. Here my index is 2, so I can think, and that instead of thinking of this as the square root of 16, this would be the same as taking 16 to the 1/2 exponent. The 1 comes from, this is 16 to the 1 power, okay? And then the 2, if you see the 2 for my index here, becomes the denominator of that fraction. And if I take 16 to the 1/2 in my calculator, I end up getting 4. Okay? So then the cube root of 8, again that's 8 to the 1, I would write that as 8 to the 1/3. And again, so now I can evaluate this in my calculator. 8 to the 1/3 is 2. And that's what we ended up getting. So if I have here the nth root of a, again that's a to the 1, this is the same as a to the 1 over n. Again, that n there is the index of your radical. The index, this is what we call a radical. This is our radical symbol, is the index of the radical. So basically now, any nth root we could rewrite as a fractional exponent. Okay. All right, so our fractional exponents, our roots here, our nth roots, can be divided up into two different groups. Either our index is even roots, so we have an even index, so that would be square root, fourth roots, sixth roots. You have an even index. Okay, so we have an even index, or we can do an odd index where we'd have cube root, fifth root, seventh root. Basically, we have an odd index. And the reason we divide them into two different groups is because you can't do an even index of a negative number and it be real. Okay? The nth root of a negative number, any negative number in here, of a negative number, again, if this index is even, is not real. Okay? That's where we get into those imaginaries, because remember, the square root of -1 is I. So that gives us our not reals, because again, my index is even. That's square root, that's an index of 2. Okay. Whereas odd roots, I can take the odd root of a negative. Sure, it's just going to give me a negative out. Okay. So if I take, like our cube root, if I did the cube root of -8, well, that's just going to be -2, because the reason for that, because -2 to the third, -2, if I put in parentheses, -2 to the third is -8. But again, -2 to any even, like let's go to the sixth, it's going to be positive 64. There's no way I can take -2 to an even power and get a negative number. That's why the even index of a negative is not real. Okay. Right. So, example 1, find the indicated real nth roots of a. So, here I want to take nth, the third root. So this tells me I want the third root of -216. So this would be written as the third root of -216. Well, I don't know my thirds that far. Okay, and I don't know if 216 is in that list, so I'm going to create some. I'm going to actually use my table to very quickly create a table of roots. I'm going to go to my y equals, and I want to take a number to the third power. So I'm just going to type in x to the third in my y equals, and then I'm going to go to my table. Okay, we already had my table set to ask for my independent. Table set, second window, independent, ask. So now when I go to my table, I can type in a 1 to the third is 1. 2 to the third is 8. 3, all I have to do is type the numbers in. 3, 4, 5, 6. Ooh, 6 to the third is 216. So -6 to the third is negative 216. So the cube root of negative 216 would be negative 6. Because again, negative 6, go back to my home screen, in parentheses, negative 6 to the third is negative 216. Okay, so we're looking at that negative 6 there. Okay, another way of thinking of this problem, or I could think of this as negative 216 to the first, and I could rewrite this as negative 216 to the 1/3. So I could take in parentheses negative 216 to the 1/3, and again we get that negative 6. Okay, and the next one, we want, this is the nth root, so this I want the 4th root of negative 81. So I want the 4th root of negative 81. So again, I could create a 4th table because I don't know my 4ths. So let's go to my y equals. I wrote it as x to the 4th. I'm going to go to my table, 1, 2. Oh, you look at 3, I get 81. But I want to get negative 81. So we can try, what about negative 3? Nope, still positive 81. So if you remember from here, an even, my index is even here, it's to the 4th. I'm taking an even index of a negative, which means this thing is not real. So I would just write not real. All right, so now evaluating these expressions. Your calculator can really take out a lot of the guesswork out of them. I'm going to do it two different ways. I'm going to do it longhand and then do it in your calculator just so we can see how it works and so we can go back and forth. If you notice, this is 16 to the 3/2. So this 2 here is my index. The denominator of that fraction is the index. So this tells me I'm taking the square root of 16 to the 3rd. Okay? Or I could think of it as the square root of 16 to the 3rd out here. So I could do the square root first and then the 3rd. Okay, we kind of want to figure out which one would be easiest. Well, the square root of 16 is pretty straightforward. The square root of 16 is 4. 4 to the 3rd. So now all I would need to type in my calculator is 4 to the 3rd. We get 64. Okay, I could have also took 16 to the 3rd to start with, over on this side. So 16 to the 3rd is 4,096, so I would have the square root of 4,096, okay? And then take the square root of 4,096, and we still get 64. Two different ways of doing it. This way, keep smaller numbers, okay? And then I can come in and check my work by taking 16 to the 3/2, and we get 64. Okay. I would really caution you to be careful to only use your calculator to check, because guess what? In the next section, we're throwing in variables. Okay, we're throwing in some variables to where you can't just type it in. So we need to know this process. Don't do too much in your calculator. Show some work. I'm going to be looking for this in your practice. Okay. All right. Okay, this next one has a negative exponent. And I'm not entirely sure if you remember how those negative exponents work from a previous section. Negative exponent, if I take something to the negative exponent, what it does is it takes the reciprocal of that number to the exponent. Okay, so first of all, this 5 is my index. So that's going to be the 5th root of 32 to the negative 3. So the negative 3 could be outside or it could be inside. Okay, it could go either place. Okay, but I don't know, 32 to the 3rd is pretty big. Yeah, I don't want to deal with a number that big, so I think I'm going to look to see, can I take the 5th root of 32? So I'm looking for fifths, 5th roots of 32. So I'm trying to find the fifths of something. So let's go x to the 5th here, my y equals, and let's say 1 to the 5th, 2 to the 5th is 32. So the 5th root of 32 is 2. But then I haven't done my negative 3 exponent yet. So then 2 to the negative 3 is going to equal the reciprocal of that, because that negative exponent takes the reciprocal. So 1 over 2 to the 3rd. Again, by taking the reciprocal, that negative exponent's gone now. 2 to the 3rd is 8, so that would be 1 over 8. Okay, so we get 1 over 8 for our answer there. All right, next page. Now we're evaluating each expression using a calculator. Round your answer to 2 decimal places. Okay, so now we actually get to use our calculator on this guy. So this is as simple as typing it in, 9 to the 1/5. But now I need to round to 2 decimal places. There's 1, 2, look behind the 5, it's a 1, so that would be approximately 1.55. Put the approximately sign, that lets the reader know, hey, we rounded that, it's not exactly 1.55. Okay, 12 to the 3 divided by 8. Okay, we get 2, approximately 2.5, and then 3, behind it's a 9, so it's going to round that up to 4. 2.54. Okay. All right, now this one we have to do a little bit of work first because this is the 4th root of 7 to the 3rd. So I can rewrite that. This index of 4 is now going to become my denominator. So I'd have 7 to the 3/4. That means the same thing. So 7 to the 3/4. And we get approximately 4.3, look, it's a 0, there's a 3 behind it, so 4.30. Okay. So now we're going to be using these to solve some equations. Okay. So we can, since we know that the 5th root of x, okay, let's look at the 5th root of x to the 5th. Well, this is my index, so the 5th root of x to the 5th would be x to the 5/5. Well, x to the 5/5 is just x to the 1, which is just x. So a 5th root undoes something to the 5th power. An nth root undoes something to the nth power. So we can use these nth roots to undo higher exponents. Just like if we had an x squared equals 16. To undo this, we would square root both sides. Because a square root, an index of 2, is going to undo an x squared. But again, by square rooting, we had to bring in that plus or minus. Whenever the index is even when solving, you have to bring in that idea of plus or minus. Because the reason for that, 2 to the 3rd is 8. Negative 2 to the 3rd is also 8. So if I cube root, oh no, sorry. Ooh, that's wrong. That's odd. Ignore that. Sorry, guys. 2 to the 4th is 16. Negative 2 to the 4th is also 16. There. Even root. I don't know what I was thinking there. Okay. So basically, then if I was to 4th root 16, it could be plus or minus 2. Okay, so we have to be keeping that in mind if our index is even. If your index is odd, you don't have to worry about it. Okay, the first step is isolate the x if you can. Okay, isolate, get it by itself, the x, meaning get rid of everything else if you can. So here I have 4, this is 4 times x to the 5th equals 128. So I'm going to get that x to the 5th by itself. It's 4 times, so I can do that by dividing both sides by 4. So x to the 5th equals 128 divided by 4, I'm going to do that on my calculator, is 32. So now I have x to the 5th equals 32. So to get rid of this x to the 5th, I'm going to now take the 5th root of both sides. The 5th root of x to the 5th is just x, because the 5th root and that power undo each other. So now the 5th root of 32, okay, I already have my 5th root list in here, so I'm going to go to my table. It would be 2, because 2 to the 5th is 32. So the 5th root of 32 is 2. So x would be 2. And you can always check your work here by plugging it back in. 4 times 2 to the 5th. So multiply that. 4 times 2 to the 5th is 128. So it did work. So my solution is x equals 2. Okay. All right. Here for example 4 part B, I can't isolate this x because it's inside an exponent. So, and it's this whole thing. This whole thing is to the 4th power. So I can go ahead and just 4th root both sides. So I'd have x minus 3 equals, my index was even, so I have to do plus or minus the fourth root of 21, which I don't think 21 is a perfect fourth. We can try it, x to the fourth. So let's go 1 to the fourth is 1, 2 to the fourth is 16. Let's try 3 to the fourth is 81. So nope, that one won't work. I think I might have typed in this equation wrong. Oh no, we're good. Okay, the fourth root of 21. And so now we'd have to add 3 to both sides to get the x by itself. So x equals 3 plus or minus the fourth root of 21. So here is our exact answer. But a lot of times we kind of like approximately's. So I'm going to get the approximately here by taking 3 plus 21 to the 1/4 and then 3 minus 21 to the 1/4. So we'll get our two approximately. So 3 plus 21 to the 1/4 gets me 5.14. Okay, and then 3 minus 21 to the 1/4 gets me 0.86 if we go two decimal places, comma. So there's our two solutions, 5.14 and 0.86. Okay, go ahead and write down your practice and get to work.